All right. Well, I did a couple examples like this today in class, and you ever in a room with a bunch of unhappy people, you could just kind of feel it in the air. The class was not happy. The class did not particularly like this type of problem. So I figure one or two of these examples that we can revisit and kind of go through at our own pace is probably a good idea. So let's take a look at this type of word problem. We've been given a certain amount of line. So the summer camp has 240 feet of float line, and we're trying to rope off 3 rectangular areas for swimming lessons. A beach forms one side of the swimming area. So what am I going to do? I'm going to kind of draw in this. Beach forms one side of the swimming area, and then I'm going to use purple for my float line. All right, and so my float line is going to come out from the swimming area. It's going to form this rectangle, and it's going to form a total of 3 rectangles. And they say the width of this is x. And so that's my variable x. And so what are we supposed to do? We're supposed to find the total area of the swimming areas as a function of x. Then we're supposed to find the domain of the function. And then we're supposed to figure out what dimensions yield the maximum area for these swimming areas. It's a bit of a mouthful of a problem here. How do I want to do this? What pieces of information do I have? I have that there's 240 feet of line. Now, my 240 feet of line, anytime you talk about rope and water, it becomes line instantly. That's that whole boats thing. Okay, so I've got 240 feet of line. And, well, what are my lengths? I have x, right? Then I have x, x, and x. So that looks a lot like 4x, right? And so that 240 feet of line, that's going to sum together to be 4x plus some unknown length, right? And so why don't we go ahead and just call that y? I don't know what it is, but let's just call it y. We could call it L, whatever we want to. All right, so if I got 4x plus y equals that 240 feet. Now, the total area of the swimming pool, the total area of all of that, well, that's just length times width, right? Or in our case, x times y will give us that area. And so that area equals x times y. But we want total area as a function of x and x alone. That second variable y is really messing us up. And so how do I actually come up with my a of x? This is really, if I was being careful with this, I would notate that that's a as a function of x and y. And I really just want that as a function of y. I'm sorry, as a function of x. I don't want any y's to be seen. Well, they've given me enough information for that because I've got an equation here where I can find y in terms of x. Just by subtracting 4x from both sides of that equation, I can get that y equals 240 minus 4x. And so that equals 240 minus 4x. Okay. And so now all I got to do is I got to replace that y with that 240 minus 4x, and I'll have that my a of x is x times 240 minus 4 times x. For the moment, let's distribute that, just because I think we're going to be a little more familiar with the type of function when we distribute that. That's going to be minus 4x squared plus 240x. It's going to look a lot more like a quadratic, right? And a quadratic, I know the basic shape of a quadratic is a bowl, but this has a negative sign in front of the bowl, so all of my y values that went up here, well, they're going to go down because they're negative. And so I know that the basic shape of this thing is going to be that bowl pointed down. And so when it asks me to find this maximum area, I know that I'm going to be able to find a maximum value for area here, and it's going to give me an x value and a y value, well, an area value and a value. And so I have a maximum area and then an x value that gives me the maximum area. That's kind of my roadmap, my plan. Okay. How do I actually get there? Well, the first thing I got to do, I'm done with A, right? This was part A. That's done. I've got my area as a function of x. Now they ask me to find the domain of the function because they want me to figure out in this particular application what x values actually make sense. Because it's really important to know, what x values in this particular application are valid. How can I figure that out? Well, let's take a look at what the physical meaning of x is. The physical meaning of x is how far away from the beach is kind of the long part the way I've drawn it, but the part that's parallel to the beach. How far away from the beach is the part that's parallel to the beach. Well, first of all, it really doesn't make sense for there to be a negative value for x, right? Because then we'd be asking people to swim on the beach. And so a minimum value for x, that sounds like a 0, right? You could quibble over whether or not we include the 0 or not. I'm going to include it. I don't think it much matters. Okay. How do we come up with a maximum value for x? Well, if x is 0, kind of the whole thing is squished up against the beach, right? That would be if x was 0 and we've pulled that parallel part. Well, how long would that parallel part be? Well, if x is 0, then this thing would be the whole 240 feet, right? What happens if x gets longer and longer because we've got a limit on how many feet? This thing gets shorter and shorter and shorter the further out we get because we've got a limit as to how much rope we have. And so what happens is we get out to a point where all 4 x's are going to be coming off the same point there. And that point is going to be what? It's going to be whatever value turns this into 0, right? We could set that up as equation, but it's also just 240 divided by 4. And so what do we got? 240 over 4 is going to give me 60. And so the largest value x would be 60. And so that's my part B. That's my domain of A of x, right? Okay. And then the last thing it said, determine the dimensions that yield the maximum area. Now, this is an algebra class. We're doing this with algebra, so we don't have things available to us like the derivative and then setting the derivative equal to 0 and solving for that. That's how you would do it if you knew calculus. And if you're watching this and you know calculus, well, that's how you would do it without the calculator. Because this is an algebra class, we're going to do a fairly brute force solution using our calculator. What we're going to do is we're going to graph this, and then we're going to use the maximum function on our calculator. And so for C, this is very much a calculator problem. We need to graph and then use the calc and then maximum function in the calculator. Well, let's do that. let's make this a little bigger just because we actually care more about the calculator right now. Excuse me. So I'm going to go to y equals, and I'm going to type in our function. It's going to be minus 4x squared, and then that'll be plus 240. And I really ought to be putting in the times x. I know a lot of the modern calculators will do implicit multiplication, but especially the old T83 pluses absolutely will not. And so I really should be explicitly putting in the multiplication every place it shows up. All right, so I got minus 4x squared plus 240 times x. That's my function. And so now I want to graph this, but before hitting graph, I want to go to my window, because that random window of whatever I graphed last time is not likely to be a good window. Now, what should these values be? We've got a pretty good idea for the x-min and the x-max because I know the domain of my function. The only x values that make sense are those that are between 0 and 60. And so the only x values that I really want to see on my graph are the values between 0 and 60. Now, the y-min and the y-max, that's a harder thing. The y-min of 0 makes a lot of sense because, that's the narrowest it could be up there. What's the longest? Well, wait a minute. This is the area. I'm confusing myself because I've used y here as a variable, but that's not what this y is about. This y is about the area of the whole thing. Let's just go with the guess. Let's just go with a guess of like 300, and we can always adjust this later. That's the y window is very much a guess and check kind of thing. All right, so I'm gonna hit graph now, and it looks like that I was very much underestimating because take a look at how high that's no, I guessed wrong. In moments like this, I think of the night at the end of the third Indiana Jones movie, when the guy's just been blown away for drinking from the wrong goblet. And the knight just very calmly says, he chose poorly. Well, I chose poorly here. Anyway, looks like instead of a few hundred, we're talking more like 3,600. All right, but I've got my 0 to 60 there, and you can see that in the graph there. And what I really want to find out is the y value. Every y value on this graph is a different possible area for our overall rectangle. And so the largest value is going to be the top of this peak. And so I want to find out what is the top of this peak. Well, it's going to look a little bit different on an actual TI-84. This is something of an emulator, and it does a very good job, and it looks a lot like an 84, but it's not exactly. There's a second button and then a calc, and I think it's the upper right button, but it's in that area if you're using a TI-84. In this case, you just see I have the calc button here. I can hit calc, and then I can go to maximum, which is exactly what you do on an 84. And then I have a left and a right, and that's exactly what an 84 would make me choose. Make me choose a left value and a right value. Now, I can't see my x-axis right now, so I'm going to close out of this, because the left and the right means choose a value to the left of where you think the peak is, choose a value to the right of where you think the peak is, and then we're going to do some sort of brute force algorithm to guess and check points until we find the actual peak. And it's a little more elegant than that, but that's the gist. All right, well, if I look at this, 20 is to the left of the peak, 40 is to the right of the peak, and so those are the values I'm going to use. If your calculator requires a guess, just use the right end as the guess. It doesn't have to be perfect. It just needs to be somewhat reasonably close to the peak. All right, so if I use a calc, I'm going to go left, and I'm going to type in 20 using a keyboard because, my keyboard's not connected anymore. All righty. Where's my keyboard? There's my keyboard. Show keyboard. There we are. Now I'm going to type in 20, not 2W. That doesn't seem reasonable. All right, and then I'm going to go to the right, and I'm going to type in 40. And then I'm going to hit enter. And what it's finding is that 29.59s. Well, something tells me that's 30. So with an x value of 30, I finally reached my y max, and my y max is 3,600 feet squared. And so when I go back over here, I kind of sketch this thing just to show where we are. So we got the 0 to 60, and I got 0, and I got 60, and I got just a nice smooth parabola going between the two. If I could sketch to save my life, that's what it would look like. And then this value is 3,600, and then that value is 30. And so for an x equals 30 feet, my a of 30 equals 3,600 feet squared, and that is my max area. Why do we care? The sarcastic of you are mumbling, well, I don't. But why should we care, or how is this useful? Maybe that's a better question. How is this useful? Well, what it does is it lets me, without going out and wasting, pounds of water sweat out in the sun rearranging ropes, it lets me figure out what dimensions I should use for the materials that I have to get the largest area, which is actually very practically useful if you were in this situation setting this kind of thing up. And so we're starting to get to the point where some of these physical models, they actually could be applied to real life and help us do things that are actually useful to us. All right, I hope that helps us with some of these word problems and applications, because I really wasn't getting a positive feel off of you guys this morning. All right, hope it helps.